Thanks to Bohr that we got the idea of the three postulate which he presented. And as I promised you before, that after the three postulate, what you will find are many more formula. In fact, this entire chapter is full of formula. Formula, derivation, numericals, MCQs. But that's the best part. For every numerical, there is a different challenge. So let's understand the first part, that is the radius, and the second part, that is the velocity. Now, my dear students, when I say I want to calculate the radius of nth orbit. Now, what do you mean by radius? I have my nucleus, then I have my electron, which is, moving, which is up. So, between the nucleus and the electron, the distance is called the radius. I want to find that. Now, how will I find R? I told you the key is, or the keys are, the Bohr postulates. Let me project the first postulate. Coulomb's force of attraction is equal to centripetal force. That's your first postulate. And what is this? Angular momentum is quantized. Second postulate. So, like to call upon the first postulate, that is mv square upon r. That was equal to k. What is k? 1 upon 4 by epsilon 0. And E is the charge of nucleus. It's a hydrogen atom after all. Small e again is the charge of electron. And r square is nothing but the radius. So my dear students, that was the first postulate. Second postulate was the one in which angular momentum, that is mvr, is equal to nh upon 2 pi. So what I will do with these two postulates? In the first postulate, what I can see is r. Second postulate, what I can see is r. Now I want my answer in which r is equal to some constant into something related to n. That means I cannot eliminate constant, I cannot eliminate n. So in the first postulate, k is a constant, I won't eliminate it. E constant, r pi j. Mass constant, r pi j. What about v? It's not easy. Eliminate. But how will I get the formula v? Look at second postulate. mvr is equal to nh upon 2 pi. So what is v is equal to? nh upon 2 pi mr. Put the value of v, that is nh is equal to 2 pi upon mr, into the postulate of first to find the value of radius. So that is how I substituted. Hey, keep on writing. I don't have to remind it again. I hope you're writing. So once you have done that, if you solve it, you cancel many terms. Take r on one side, take n square, h square on the other side, and So what I will get is r is equal to n square into bracket h square upon 4 pi square m e square k. My goodness. All these things in the bracket, they are constant. So that constant has one value, that is 0.53. So my Rn is equal to 0.53 into n square. What is 0.53? And it's a constant, but what? That constant is nothing but R1. The radius of first orbit of hydrogen atom. Remember the values. R1 is equal to 0.53 Armstrong. So what is Rn is equal to R1 into n square. So what is Rn proportional to n square? Simple. Thus the radius of the Bohr orbit is directly proportional to the square of principal quantum number. Simple enough. Very easy. Please remember this formula. You will have to remember this one. It's a little bit big, but it can be managed. This equation gives the radius of nth Bohr orbit. That is for clear. But after this, after noting this formula, what I come across is the calculation of linear velocity. Now, when I say linear velocity, what comes into my mind? Oh! Look at the electrons coming here and there. Yes, perfect. So that's the linear velocity. Or can I say, if I want linear velocity, again I will use two Bohr postulates. Remember, I told you before also, to get all the formula, I will use all the three postulates of Bohr, and that's what I'm using it, first and second postulate. So from this first and second postulate, I got R is equal to n square into 0.53, just in the previous derivation. What I will do is, in that equation, I'll put the value of R. So let me take out V. So for me, V will be equal to this. Then let me point R, and let me take down to this equation. So V is equal to NH upon 2 pi M, and put the value of R. Cancel, and you will get this. Oh wow. V is equal to 2.2 into 10 raised to 6 upon N. What is 2.2 10 raised to 6? Just like 0.53 was R1, 2.2 here it will be what? V1. So my dear students and gentlemen and ladies, from these two postulates I can say that I got a two formula of radius and velocity, where radius is proportional to n square, velocity is inversely proportional to n. And what is 2.2 into 10 raised to 6? That's the velocity of first Bohr orbit, V1. And that is how the velocity turns, round and round and round and round. I hope this was clear, because in our next module we come across more other parameters, and with that parameters you will understand the depth of this chapter. Thank you.